do some explanations as to the justification of the correct responses to the given set of questions given. Right, as you know, our paper is made up of 3 basic questions, which is question number 1, climate and weather, based on the topic climate and weather. And the question number 2 on theory is based on geomorphology, which is our fluvial geomorphology, the study of rivers. Right, then question number 3, as usual, is geographical techniques, which is our Mapwork. Right, so we're going to start with the first question, which is question number 1 on climate and weather. Right, there is an urban heat island isotherm map below, which is given here. Our isotherm maps we are referring to maps that show the distribution of temperature in a given place. And our isotherms, we are referring to these lines here that we see on the map. These lines, they are joining places of the same temperature that we call the isotherms. Right, so going to our questions, we want to use this illustration here to answer the questions. We are seeing this is the CBD, which is the central business district of this area. We are seeing the isotherm reading, which is surrounding the CBD, is positive 6, which implies that the temperature closer to the CBD is around positive 6 degrees Celsius. And in the rural areas, the surrounding rural areas, the surrounding farmlands, we are seeing the isotherms readings is positive 2, and the last one at the outermost part is reading positive 1. So that's the implication of our isotherms. You see they are ranging from a positive 1 on the outermost part of the built-up area, and closer to the built-up area, our isotherm reading is positive 6. Right, let's go to our questions. Right, our first question is saying the temperature range between the CBD and the rural area is. Right, when we're talking of a temperature range, we are looking at the difference between the highest temperature recorded and the lowest temperature recorded. So if we check from our illustration, we are seeing that our CBD, the temperature isotherm reading here is positive 6, and the rural is positive 1. So we are saying the temperature range is the difference between positive 6 and positive 1. That gives us 5 degrees Celsius. So our correct response is item number D, which is 5 degrees Celsius, which we find by getting the difference between the highest temperature, which is closer to the CBD, and the temperature of the rural area, which is positive 1. Right, we move on to the next question. Increase the surface area for the absorption of solar radiation and restrict the cooling. We are looking at increasing the surface area of the absorption of solar radiation and also restriction of cooling effect of wind. Which one is likely to give that effect in the CBD? Right, the correct response is tall buildings. The tall buildings, they have a larger surface area for the absorption of solar radiation, and also they restrict, because of the height of the building, they restrict the cooling effect of the wind. Remember, the winds in the urban areas or in the CBD, they are channelized such that they do not pose a cooling effect in the CBD. Right, moving on to the next question. Rural areas have lower temperatures because they have a dash and also a dash albedo and dash water bodies than rural areas. Right, what is it that we call albedo? We are looking at reflectivity. Right, so albedo basically refers to reflectivity effect. So rural areas have got lower temperatures because they have what kind of albedo? We are saying the albedo in rural areas is higher, and dash water bodies than urban areas. And also we tend to find that we have more water bodies. The water bodies, they are responsible for producing a cooling effect because of evaporation, and also because of high reflectivity, we tend to have much of the heat being lost back because of reflective effect. So item number 1 and our item number 4, they combine to give us the correct response at item C. Right, on our responses. Right, moving on to the next question. 1.1.4, it says the suburban areas are cooler than the CBD, right? If we look at the suburban areas on our illustration, our suburban is here. The suburban area is slightly cooler than the CBD. The isotherm reading is +6, close to the CBD, and around here is positive 4. It's in between positive 4 and positive 3. So we are seeing that the suburban area is cooler compared to the CBD. Right, let's analyze the question. The suburban areas are cooler than the CBD because they have dash artificial surfaces. We know well that artificial surfaces are responsible for the absorption of heat. For example, we talk of the tarmacs and we talk of concrete surfaces. They are responsible for the absorption of heat. So in the suburban area, we are saying there must be fewer of them, which will lead to a reduction in the temperatures. So we are saying item fewer for artificial surfaces and dash evapotranspiration. Right. We are looking at the release of moisture from vegetation, that is evapotranspiration and combined with evaporation. Right. So we are saying what is the level of evapotranspiration in the suburban areas? Automatically, it has to be higher so that we have a cooling effect compared to the urban CBD. So our correct response is matching item number 1 and item number 3, which is on response number C. Right, moving on to the next question. Right, if you see this question here is talking about a pollution dome. Right, whenever we're talking of a pollution dome, remember we are looking at a situation of the concentration of pollutants in an urban area. Right, so if we are looking at this illustration here, ultimately we can see that there is high concentration of pollutants in this built up area in this CBD. Right, so by analyzing the situation, I will try to illustrate before I answer the questions. We have a situation of our pollution dome during the day. Right, how does the pollution dome look like during the day? During the day, if you are to look at the shape of the pollution dome, it portrays a shape like this one. We are saying our built-up area is here, and the concentration of pollutants will have a picture like this one. Here we have a form like this, and our pollutants, they will be high in the upper atmosphere. Why will they have a shape like this? Is because there will be convection currents which will be experienced in the urban area. Remember, the urban area will be having an urban heat island situation. There will be high temperatures in the urban area, and that will result in a low pressure system developing around the urban area. As a result, compared to the surrounding rural areas, these rural areas surrounding the urban area will be having higher temperatures compared to the CBD. And as a result, there's pressure gradient that results in the air movement into the urban area from the surrounding rural areas with lower temperatures. And this is going to cause convection currents, and the convection currents are going to uplift the pollutants into the upper atmosphere, such that during the day, the concentration of the pollutants is limited, and the pollutants are lifted up the urban area. That is the day situation. And let's analyze the night situation. Right. The effect of pollution domes is mainly more evident during the winter season. We experience the effects of pollution domes more predominantly during the winter season. Right. During the night, we tend to have a different situation of the pollution dome. The pollution dome now at night, it looks like this. It now portrays the actual dome shape. Right, and our buildings in the CBD will be like that. In the urban area, right, we are saying that is the situation at night. So what is happening is the pollutants now are concentrated. If we see now, the pollution dome has lowered. It has now been lowered. It's now lower. It's just above the tallest buildings. And meaning to say it's now compressing the pollutants, and they are concentrated closer to the ground surface, affecting the residents of the urban area. Why is it like that? It's now because during the night, the urban area is no longer experiencing a low pressure system. It's now cooler during the night, and also at night, there is now the strong effect of the descending air from the Kalahari high pressure cell. Remember, we're talking of the winter season here. the dominance of the Kalahari high pressure cell will force the pollution dome to lower itself, and ultimately it is going to cause a concentration of the pollutants closer to the ground surface, and that is going to ultimately affect the residents in the urban area because of the concentration of the pollutants. So if we try to relate that to our illustration that is given here, we are seeing that there is high concentration of pollutants in this built up area, in this urban area. That is typical of a night situation, right? So using that explanation, let's go to find out the relevant responses to the given set of questions. Right. Our first question is saying the photo represents a pollution dome during, we have explained that is a night situation. Because of the concentration of the pollutants, we can ultimately justify that the pollutants are concentrated, and that will happen during the night. Right, moving on to the next question, number 116. In the photo, the pollutants are concentrated dash the earth surface due to a dash in the upper A. Right, why are they concentrated? Where are they concentrated? They are concentrated closer to the earth surface. This is our response on the first part. They are closer. And why? Because of the dominance of the Kalahari high pressure cell. I think we have discussed that. So the high pressure cell is the one that lowers the pollution dome, is the one that forces the pollutants to lower their level and ultimately concentrate close to the ground surface. So our correct response must be matching item number 2 and item number 4. That is on response number D. Right, moving on to the next question. Pollutants in the pollution dome mix with radiation fog to form. The mixing of pollutants with fog, they form what we call smog. Right, we move on to the next question, 1.2. It talks about a matching question. Right, it's a matching question. We're going to analyze the matching questions and try to figure out the right responses. Right, number 121, it says this slope is suitable for forestry in the southern hemisphere. When we're talking of slope aspect, remember the concept of slope aspect, we are looking at the orientation of slopes. If this is a southern hemisphere slope, we are saying this side is our north-facing slope and this side is our south-facing slope. Because of the position of the sun, mainly during the winter season, the sun is always lower in the atmosphere, implying that this part of the slope is the one that receives insolation, which is our north facing, while this part here is facing away from the sun. So when you're talking of forestry in this instance, we know that our forestry requires the cooler part of the slope. So our correct response is south facing. Here, that is where we tend to grow crops that require amounts of sunlight, because this is the one that is facing to the direction of the insolation. Right, we move on to the next question. This precipitation forms when the temperature in the valley is above a freezing point. When the temperature is above freezing point, we tend to have accumulation of water droplets on the ground surface and on vegetation. And that kind of precipitation is the one that we refer to as the dew. Right, usually you tend to find that in clear cloudless nights of the winter season. In the morning, you tend to find that there's accumulation of water droplets on the ground surface and on vegetation. That is typical of dew. But frost happens when the temperature is below freezing point. If temperatures go below 0 degrees Celsius, ultimately we are going to have a frost situation. But here is above, it means our correct response is dew. Right, number 1, 2, 3. It says it traps pollution in the valley during the night. What situation are we referring to? What geographical phenomenon is responsible for the trapping of heat of pollutants during the night? That is our thermal belt. The thermal belt is the one that is responsible for the trapping of pollutants. And the thermal belt, basically, we are looking at a belt of warm air which occurs all the valley sides. Like here, we are having cold air from the bottom, and also we are having cold air descending. and then we have a belt of warm air. This is typical of a thermal belt. And if there are pollutants that want to escape from the valley, ultimately they are trapped by this belt of the warm air, which is our thermal belt. Right, we move on to the next question. The next question is saying precipitation which will impact the precipitation which will impact farming products. What kind of precipitation is likely to impact farming products? Right, our correct response there is frost. When we have frost, ultimately it means the nature of crops that we must grow in that area, we need only to grow what we call the frost resistant crops. Those crops that do well in extremely cold conditions. Otherwise, if we grow crops which are not resistant, ultimately it means they are going to be affected by the frost. They are going to dry out because of excessively low temperatures. So it's going to affect the impact on farming products because of the frost. Then number 125, it says forms when air cools to dew point as a result of terrestrial radiation. Right, terrestrial radiation is the same as long wave radiation, which is the loss of heat from the ground surface into the atmosphere. That usually happens during clear cloudless nights. When we have calm, clear, cloudless nights, we have excessive radiation. The nature of phenomenon that forms when air cools due to the long wave radiation is what we refer to as radiation fog. Right. Moving on, number 126, people living on the valley slopes experience during this wind during the day. Right, we want to experience a situation, we want to look at a situation of the valley climates. During the day, we have upslope winds, and those upslope winds in a valley, we call them the anabatic wind. And this is an upslope wind, and it's a day wind. This one is a downslope wind, which is typical of night conditions in the valley. So it's anabatic. Then moving on to the next question, a wind that develops in a valley during the night. The night is a downslope and is typical of the wind at Y, which is katabatic. Right. Moving on to the next question, houses are built at this location to lower electricity bills. Is it Z or Y? Z is in the valley floor. That is where we experience frost pockets during excessively cold winter nights. And ultimately, they cannot reduce electricity bills because we need heating because of excessively cold temperatures in the valley. This is where the thermal belt exists around area Y and is the warmer part of the slope. So the correct response is Y for number 128. Right, moving on to the next question. It's a synoptic map. Right, what do we call a series of mid-latitude cyclones? A series of them is called a family. It's a family of cyclones. When they occur in series, we call that a family of cyclones. Right, name the front A and B on the synoptic map. Right, what differs between those types of fronts, we must just figure out like our A, if we try to check, our nature of the front is like this. And if we see this symbol, it means this is a cold front. And if our front has got this symbol, which is more like a semicircle, it means that is a warm front. Right. Moving on to the next question. What influence does the South Indian anticyclone, as shown on the synoptic map, have on the path followed by the mid-latitude cyclone? Right. If we have the South Indian here, this is a high-pressure cell and anticyclone, and we see our mid-latitude cyclones are moving in that direction from the west going to the east. Apparently, they're going to be blocked. This is also what we call a blocking high. And they are going to be twisted in a given direction. They cannot pass through a high pressure cell here. Ultimately, they are going to be forced to tend to this direction as they go in that direction, as seen by the presence of the high pressure cell here. They are being blocked by this high pressure cell, apparently changing their direction as they try to move towards the eastern direction. So we are saying our South Indian is also regarded as a blocking high. It acts as a blockade to the movement of the tropical, to the mid-latitude cyclones. And how it will force, because of its presence, it will force the mid-latitude cyclone further to the south. They are forced further to the south because they are being blocked by the presence of the anticyclone along their way. Right. The mid-latitude cyclone at sea is in the cold occlusion stage. Draw a labeled cross-section at sea on the synoptic map. Right, we are looking at this point C here. We are saying it has reached an occlusion, and the occlusion is a cold front occlusion. Right, so when you're drawing this as a cross-section, you know our cold front is steeper, so it must be like that. Then our warm front must start from somewhere there and is gentle. So this is our ground surface, and this is our west, and this is our east direction. We know the movement direction is always in that direction. Right, so given that we want to check on the mark allocation so that we are able to identify the given features of the mid-latitude cyclone, we are saying the shape of the cross-section must be in such a way that it is the cold front that touches the ground because it's a cold occlusion. So we must have the cold front proceeding to touch the ground surface here to show that it's a cold occlusion. Our warm front starts from the top, touching the cold front, going in that direction. And we want to indicate the direction of the cold air. So we must label, this is our cold front, and this is our warm front. Right. So where is the cold air? The cold air is from behind here. And this one becomes the cool air. And where is our warm sector? Our warm sector comes here. So that's basically how it looks like. It's cold air behind the cold front, and in between the warm front and the cold front, there is warm sector, which is a zone of warm air being uplifted. Then there is cool air ahead of the cold front like this. That is basically what qualifies you to get the 4 marks for the illustration. Right, moving on to the next question. Account for the development of the weather at Cape Town experienced on 3 July. Right, on 3 July, we're experiencing the landfall of this mid-latitude cyclone. How is it going to affect the weather? The question says account for the development of the weather at Cape Town, which means we must give reasons for the different weather developments that are going to happen at Cape Town. Right, we are going to experience cold conditions or low temperatures. That is typical of weather conditions. And where is it coming from? What's the reason for the cold conditions as the cold front coming, as the mid-latitude cyclone is coming? We are looking at the coming of the cold front. The cold front is going to bring in cold conditions in Cape Town. And we can also talk of high precipitation. We experience high forms of precipitation around Cape Town as the cold mid-latitude cyclone approaches. Where does the where does the high precipitation come from? Is because of intense condensation. Because of upliftment of warm air. As the warm air is uplifted, it condenses and produces rainfall. Then we also have overcast conditions or high cloud cover. Is because of, again, upliftment of warm air. As the warm air uplifts, it condenses, creating clouds. And predominantly, we talk of the cumulonimbus clouds, which we know are rain-bearing clouds. And also, we can talk of strong winds are likely to be experienced. The strong winds, they are caused by the approaching cold front. is going to cause strong winds around Cape Town. Then you can also talk of other weather phenomena like thunderstorms are likely to be experienced. Thunderstorms, we know well that they are associated with the cumulonimbus clouds. As those clouds form, they likely facilitate the development of thunderstorms. So those are typical weather conditions that you can talk about, which are likely to be experienced around Cape Town as the mid-latitude cyclone approaches the area. Then we go on to the next question. Is based on an infographic on tropical cyclone Khamani. Right. The infographic has all the information. We cannot go through it. We want to answer the questions. How many tropical cyclones had developed before tropical cyclone Khamani? Right. What you must note here is tropical cyclones are named alphabetically. According to geography, we name our tropical cyclones alphabetically, meaning to say we want the number of tropical cyclones which have occurred before tropical cyclone Khamani. So if we check on our alphabet, we are saying for us to get from A to alphabet G, how many alphabet letters are there? G, as we note here, is our letter of the alphabet on number 7. So if you are saying from A to G, there are 7. We want the number of tropical cyclones which have occurred before. That's the question. So which means before, if this is the 7th, it means before we have had 6 of them. Right. When did tropical cyclone Khamani make a landfall? According to the infographic, our information, we find it here. Tropical Khamani made a landfall in that area, bringing heavy rainfall and floods on 27 March. According to the map, to the infographic map information, it made a landfall on the 27th of March. Right. Describe the general direction followed by tropical cyclone Khamani. We want to go to the infographic and check on the general direction. We are seeing on 26 March, it was somewhere here. On the 27th, 29th, and on the 31st, it was going in that direction. So if we try to analyze that movement direction, how is it moving? We can justify that this is basically a north-westerly direction, and they were approaching, going towards the southeasterly direction. That is basically the movement direction. It was coming from the northwest, drifting southeasterlywards. That was the movement direction of that tropical cyclone from 26 March until it got to 31st of March. Right. Discuss the negative environmental or natural impact of tropical cyclone Khamani on the coastal regions mentioned in the case study. Right, if we try to check the impact here on the coastal areas, it says began developing along the northeastern coast of Madagascar. Some districts in the northeast have received heavy rainfall over the past few days. So we are looking at the impact of heavy rainfall on the natural environment. How does it impact? Discuss the negative environmental or natural impact of tropical cyclone Khamani on the coastal regions. Right. Because of the heavy rainfall, can have the risk of flooding of the coastal areas, which is going to affect the natural environment. Or we can talk of increased soil erosion. The heavy rainfall is going to cause an increase in soil erosion that is going to affect the natural environment. Or we can also look at the impact of loss of habitat. It can be a negative implication. If there's heavy rainfall, we're likely to have a destruction of the natural habitat of wildlife or of the habitat of the natural vegetation. And we can also talk of the disruption of the natural ecosystem. It can also be disturbed. The natural ecosystem can also be disrupted by the heavy rains. So when you're looking at this question, we want to look at the natural environment only. Our response must be inclined towards the natural environment. Right. Then in a paragraph of 8 lines, explain why Madagascar is still vulnerable to the effects of tropical cyclones, despite huge improvements in early warning systems and disaster relief programs. So we are excluding this effect here. because Madagascar has managed to improve in early warning systems and also in disaster relief programs. We want to identify other factors which are making Madagascar still vulnerable despite those efforts. We know that those are alleviating efforts towards the dangerous effects or towards the harmful effects that are caused by tropical cyclones, and Madagascar has furthered itself towards the development of those areas and is still vulnerable to the impacts of those natural disasters. Right. So what might be the implication? Right. We can talk of the geographical location. The geographical location of Madagascar. Where is it located? We are seeing that Madagascar is located on the southwestern Indian Ocean basin. South is located on the southwestern Indian Ocean basin. This area is prone to natural disasters like the tropical cyclones. So despite the efforts, the geographical location will still expose it to the dangers of the tropical cyclones because of its location. That is where most of the natural disasters strike, especially the tropical cyclones. They strike that area because of its position. Madagascar is still vulnerable. It will still be affected, and it will still be affected because it's frequent. The location, its geographical location facilitates frequency of the happenings of those natural disasters. And also, we can talk of Madagascar being inadequate infrastructure. We are looking at the nature of infrastructure in Madagascar. We are looking at infrastructure like roads or bridges or the buildings. They are not meant or they are not strong enough to resist the strong winds which are associated with tropical cyclones and also heavy rainfall. Such that despite the early warning systems, they are still prone because of the nature of infrastructure that they have. And also we can talk of the frequency of natural disasters. Like for example, the tropical cyclones, they are more frequent in that area, meaning to say despite the efforts, they will still be affected because the frequency is very high. And also it will weaken the resilience. If you are frequently affected, it means it will weaken the resilience to those disasters. So instead of them developing resilience, they will not ultimately find time to strengthen their resilience because they occur frequently. Right, and also we can talk of the problem of climate change. It has also affected climate change, which is prevalent. It has also affected. It is now intensifying the cyclones. For example, because of global warming, we tend to find that the temperatures of the oceans are increasingly becoming higher, and we know well that the tropical cyclones are favored by the higher ocean temperatures. So because of the climate change, we also tend to find that the tropical cyclones are intensifying. They are getting stronger and stronger because of climate change. They are being fueled by climate change, their strength, such that despite the relief programs, we will still have them destroying infrastructure because they are getting more stronger and stronger around the areas where they affect. Right, that was question number 1.44. We move on to question number 1.5, which is based on warning for Durban. Right, our map that we have here, we understand this is a cold front which simplifies the movement of the mid-latitude cyclone. And if we check over the interior, we have the high pressure cell, which is typical of the Kalahari high pressure cell. Right, let's analyze our questions. Define the concept Berg winds. Right, when we are defining these concepts here, we need to capture the idea of the Berg winds. Right, we can define it as a hot, dry, gust wind. Right. And we need to have described it as what kind of nature does it have? It's hot and dry and gusty. Right. How does it develop? Or where does it affect? That affects the coastal areas of Southern Africa. And how does it result? It results from adiabatic heating of air descending from the plateau. I think we would have addressed the basics of the Berg winds. What nature of wind is it? Is a dry, hot, gust wind. Where does it affect? It affects the coastal areas, Southern Africa. And how does it result? It results from adiabatic heating of descending air, which comes from the plateau because of the dominance of the Kalahari high pressure cell and the existence of the coastal low around the coastal regions. We have pressure gradient between the plateau and the coastal areas. So as a result, we have the air being forced to go down the escarpment and it reaches the coastal areas. And as it goes down, it heats up adiabatically. What we say with adiabatic heating, we are saying the air heats up without the influence of the environment. It heats up because of changes in pressure as it goes down the escarpment. Right. According to the weather map, which two pressure cells are responsible for the occurrence of the Berg winds? The Berg winds, they occur as a result of this high pressure cell, which is the Kalahari high pressure cell. And they also occur because of the presence of the coastal low pressure cells. These two cells are the ones that facilitates the development of the Berg winds. They occur because of the dominance of the Kalahari high pressure cell over the interior, and this high pressure cell will be causing descending air, and there will be pressure gradient because there will be a low pressure cell around the coastal areas, and because of that differences in pressure, we tend to have air drifting down the plateau and from the plateau going to the coastal areas, and that is going to affect the air as it goes down, it heats up adiabatically, and it is going to cause the Berg winds. Right. A Berg wind is an example of, is it an onshore or an offshore? We are saying the winds are coming from the plateau going to the ocean, which is offshore. Explain why the South African Weather Service issued a fire danger index on 4 August. We are expecting the coming of the Berg winds. Why did they issue out a fire danger index? There is possibility that there is high chances of fires occurring around the coastal areas. Right. What facilitates the fires? Right, we are saying the Berg winds. Let me try to explain here. The Berg winds create conditions that cause wildfires. It facilitates conditions that cause wildfires. What are the conditions associated with the Berg winds that facilitate wildfires? For example, we are saying it has hot, dry air. How does it facilitate? It can dry vegetation, can dry up vegetation. And as vegetation dries, that is likely to causing fire. And also, what are the other factor? We are saying there will be low humidity. The air will be dry, low humidity. And if there's low humidity, we are saying it makes it easy for fire to spread. If there's low humidity, fire can easily spread. And also, if we check, there will be also strong winds. We said it has gust winds, which are strong winds. And strong winds, they have the capability of fanning the flames. And spreading fires. Rapidly. So those conditions associated with the Berg winds, they facilitate the development of wildfires. So because of its conditions of being hot and dry, it can dry up vegetation, and as vegetation is dry, it also leads to veld fires. And remember, these Berg winds, they occur during the winter season. We know well that during the winter season, most of the vegetation is dry. The natural vegetation is usually dry during the winter season. And because of that reason, fires can easily start if there is hot, dry air. And also because of the frictional effect, if it has friction with the ground surface, fires can easily start if there is dry vegetation or if there's dry matter on the ground. Because of the frictional effect, it can easily spark fires. And because of low humidity, we are saying the air that will be blowing in a Berg wind condition will be dry winds, and those dry winds can facilitate fire to easily spread. And also because the winds are strong, they can fan the fire, and the fires can become very wild and spread rapidly. Right. Then the next question is saying, suggest strategies that the local government can implement to reduce the impact of Berg winds on the natural environment of the coastal regions of KZN in KwaZulu-Natal. What can the municipality do to try and reduce the impact of the Berg winds? We know well that the danger is mainly with effect of fire. So what can we do to reduce the impact? Right, I'll just try to highlight some of the strategies. We can talk of here, we can create fire breaks. The fire breaks, they will assist in stopping the spread of the fire on the natural environment or containing the spread of the fire over the natural environment. That is going to assist in the fires not spreading. Or we can also try to keep the ground wet, if possible, so that if there is humidity, the spreading of the fire will be limited and will have less impact on the environment. And also we can talk of emergency planning. If we have emergency measures in place, we can try to limit the effect of the veld fires on the environment. We can try to limit, if for example we have emergency ways of stopping the spread of fire or of getting out the fire in an emergency situation, then it means we are going to lessen the burden on the environment. And also we can talk of public education can also assist educating the people on how to reduce the impact of the Berg winds on the environment, so that people will take the initiatives at household level and do not disregard the damage that was going to happen on the environment. Or we can talk of vegetation management. Vegetation management. How can we manage the environment through managing vegetation? Right, we can plan well ahead before the veld fires are likely to spread. For example, we can do thinning of vegetation to reduce the impact. If vegetation is thinned, it means the impact of the veld fires, if they happen to exist, will be lessened because there will be less matter to be burnt, and apparently the spreading of the fires will be limited, right? So those are some of the strategies that can be implemented or can be put in place to try and limit the impact of the Berg winds on the natural environment. Right, we need to move on to the next question. That takes us to the end of our climate and weather question. We move on to our geomorphology question. Right, our geomorphology question, basically, we understand we are looking at fluvial geomorphology, we are looking at rivers. Right, we are having this illustration, which is showing a situation of stream piracy. Right, I'll try to explain before we answer the questions. I'll try just to give a highlight of the situation which is happening here. Right, as you see, we are having river F. Our river F is in its own drainage basin, is split by this high-lying area, which is labeled a watershed. Remember, a watershed is a high-lying area that separates two distinct river systems, or that separates two drainage basins. Then we have river G on this extreme side. Is happening also to exist on its own drainage basin. And what happens with this situation of stream piracy? We are saying when the stream piracy occurs, we have a more energetic river. This river here is more energetic, meaning to say it has more erosive power. And this one is less energetic. A river which is more energetic is the one that flows over a low-lying area. It easily advances towards the watershed. And this one is the one that is flowing on a high-lying area. It has less energy. It's flowing over a high-lying area. The river that is flowing on a low-lying area can easily advance towards the watershed. There is what we call headward erosion, which happens. And because of headward erosion, this is a type of erosion which is responsible for lengthening the river channel. The river channel becomes longer and longer because the source of the river keeps on migrating. The source of the river keeps on migrating headwardly, advancing, and the river becomes longer and longer. And because of this nature of erosion, we tend to find that this stream is gradually advancing towards the watershed and will eventually reach River G. And as it reaches River G, it is going to intercept the headwaters of River G into the flow of River F. That's typically the situation of stream pirates or river capture. Right, let's go to our questions and try to quickly answer them. Right, River F is the captured or captor. Right, we are looking at River F. River F is the one which is capturing. So is the captor. Is the one that is intercepting. Right, we move on. Is headward or lateral erosion dominant at D? If you go to D here, we are seeing that this stream is advancing, and the nature of erosion responsible for advancement of rivers is headward. What we call lateral, this is sideway erosion, is responsible for widening the river channel, but headward is the one responsible for lengthening the river channel and making the river longer. Able of capture will most likely occur at E or C. What we call an able of capture, that is the bend where piracy takes place or where interception takes place. So the bend, where is it likely to occur, at E or at C? E or at C here, we are seeing that E is below. This stream is going to advance, going towards C, and that is where the bend is going to occur. If this stream keeps on advancing, it's going to intercept somewhere around C here. So the correct response is C. Right, wind gap will most likely develop at E or A. What we call a wind gap, that is the gap between the able of capture and the misfit stream. If the stream is captured, there's going to be a gap between that angle of capture like this. The bend is here. Where is the elbow of capture? It means this stream has captured this, and there is a bend here, which is an able, and there will be a misfit stream, which is going to continue. The wind gap is going to occur here between the two. So if we are using this information, where is our wind gap to develop? It is going to develop around E here. This will becomes the misfit, and around E becomes the wind gap. So our response for the wind gap is response E. Right, moving on to the next question. A misfit stream will form in river. Is it F or G? A misfit, we said, is going to form here as this river continues. So it's going to form at G. Then after river capture occurs, erosion or deposition will increase at A. Let's look at where is A. At A here, this stream is going to capture, and there will be high discharge, and there will be high velocity around area A. So because of high discharge and high velocity, our erosion is going to increase, and there will be less deposition. Velocity of river G will increase or decrease after B. At B after river capture, where is B? B is here. There will be less discharge here, implying that the velocity of the river is going to decrease. The velocity you are looking at, the speed of flow of the river. If there's less discharge, there's less water, the velocity is going to be less. But if there's more discharge, there is going to be high velocity. So because of stream pirates, that stream has been captured, which implies that it's going to have a less velocity because of the less discharge. Right, moving on to the next question. Right, it says, after water flowing at, the water flowing at X in the sketch below is described as what kind of flow? Right, we are seeing that this is our drainage basin and our river is here. our level of the flow of the channel is here, the river is flowing here. So at X here, we are looking at a situation whereby the river is flowing on the surface and is going to feed into the river. So this is sheet flow or surface runoff. Right, we move on to the next question. The feature at A in the photograph below indicates A or N. What is the likely feature here? We are seeing there is a stream which is coming from this side, meeting a stream which is coming from that side, and around A, that's the meeting point. So the meeting point of two streams, we call it a confluence. Right, move on to the next question. Dash is being extracted by the borehole in the sketch. Right, if we check the borehole here is extracting water from the ground. So ultimately the borehole is going to extract water from our ground storage, which is our groundwater. Right, the level of the water table will be dash at A because of the dash vegetation cover. Right, if there is vegetation cover, the implication of vegetation cover is that it's going to increase the infiltration level of the rainwater into the ground storage. So because of the presence of high levels of vegetation around area A, we are likely to have our water table being higher because there is more water being fed into groundwater storage. We tend to have more feeding in of water into groundwater storage, and then that will result in the upliftment of the upper zone of saturation of groundwater, which is our water table. So it's going to be higher because of the facilitation of infiltration by the presence of vegetation in that area, because of the presence of vegetation. So our item number 1 and item number 3, they constitute to give us our correct response. So we say our correct answer for that one is item number 1 and item number 3. They meet at C. Item number 1 and item they meet at item is saying to be higher. The water table will be higher at A, right? And is because of the presence of vegetation. So our correct response must be item A, which matches higher and which matches the presence of vegetation, which qualifies our response to be correct at item A. Right, we move on to the next question. The next question is saying, the sketch below shows an dash profile. Which kind of profile is this? If we check, the profile that we are being shown here is showing one bank and is showing the other bank of the river. We are seeing the stretch of the river from one bank to the other bank. So ultimately, we have two profiles of the river. We have the longitudinal and we have longitudinal profile, and we have the cross profile. The longitudinal profile shows the stretch of the river from the source to the mouth, while it's the cross profile, it shows from the bank to the next other bank on the other side. So our cross profile is also called the transverse profile. It's one and the same thing. So our correct response is A, which gives us the river's transverse profile. Right. We move on to the next question. 2.26. 2.26 says the dominant fluvial process in the upper course of the river is. In the upper course of the river, the dominant fluvial process is erosion. Why do we have high levels of erosion? It's because of gradient, which is steep. And because of the steep gradient, we have high velocity of flow. And because of the high velocity, it facilitates erosive power of the river. The river is more energetic in the upper course. Right. The presence of a dash in the river profile indicates that this river is ungraded. An ungraded profile. What evidence do we have there which suggests the river is ungraded? There is a lake that you are seeing inside along the longitudinal profile. So that lake suggests. And what is this lake? It's a temporary base level of erosion. So it's temporary in the sense that it can be eroded and it will disappear if the river achieves grade. So the presence of the lake along the longitudinal profile suggests that the river is ungraded. When a river is graded, it has a balance between erosion and deposition. It gives a smooth concave shape from the source to the mouth. If it has an undulating slope from the source, it has nick points. If it has waterfalls along the river channel, it means the river is ungraded. It hasn't reached a balance between erosion and deposition. Right, we're moving on to the next question. Number 2.28, it says the presence of a nick point waterfall in a river course indicates that dash has occurred. What facilitates the development of nick point waterfalls is because of rejuvenation. If a river has renewed its energy, it will ultimately start eroding again. And as it erodes, and if it reaches a point where there is a hard and resistant rock, it will ultimately fail to erode it effectively, and there will be the formation of the nick point waterfall. So ultimately, it's because of rejuvenation that will make the river have that presence of the nick point along the river channel. Right, moving on to the next question, which is question 2.3. The question is basically based on the two drainage basins, drainage basin A and drainage basin B. And those two drainage basins have got different drainage patterns. We want to start by analyzing the two illustrations and try to make simple explanations so that we can use those explanations to justify our responses to the given set of questions which are going to follow. Right, if we look at this drainage basin here, it has a typical pattern of these streams which are bending at right angles and which are also joining the main stream at right angles, if you can check. And if you check, the major stream is also bending at a right angle like that. And this tributary is also joining at a right angle and is also bending at right angles. So if we check this nature of a drainage pattern, this is typical of a rectangular pattern. Right, and let's go to drainage basin B. If we check, our main stream is this one, and if we check our tributaries, they are joining at acute angles or at angles less than 90 degrees. And also if you check how the tributaries are joined by sub-tributaries, they are also joined at angles less than 90 degrees. And this nature of drainage pattern is what we call dendritic. Dendritic, which is a derivative word from the word dendros, and dendros meaning a tree and its branches. This pattern resembles a tree and its branches. Like if this was the stem of the tree, this is going to be the branches and the sub-branches of the tree. It resembles a tree with its branches, which is dendros, which is a Greek word, and that is where our term dendritic was derived from. So those are our two patterns. And if we try to analyze the nature of the underlying rock, which facilitates the development of these two drainage patterns. For rectangular drainage pattern, we are looking at a situation whereby the underlying rock is hard and resistant, but is a cracked rock. Rocks which are cracked or rocks which are jointed. The rocks are hard and resistant, but they are cracked or they are jointed, such that the streams, they follow within the cracks of the rocks. And because of the nature of the cracks, they will also tend to determine the type of the flow over the area. They will be following the joints or the cracks of the underlying hard and resistant rock, such that they will end up having this shape of a rectangular. And here we have rocks of uniform resistance. That is why we tend to find the pattern forming like that with acute angles. The rocks will be of uniform resistance. Right, let's go to our questions. Right, name the drainage pattern evident in drainage basin A. We have answered that. The drainage pattern there is rectangular in A. Right, mention one characteristic or feature of the drainage pattern evident in drainage pattern A. The feature, right, the streams, if you check, they meander at right angles. And also, if you check, they join at right angles. That's the major feature there, according to our observation. Describe the underlying rock structure that influence development of the drainage pattern A. We've talked about that. It develops where we have jointed or where we have cracked rocks underneath. Right. So the rocks are jointed or they are cracked, and as such, streams follow the joints or the cracks to add to that. The underlying rocks are hard and resistant, but they are cracked or they have joints, such that the streams which form on the surface, they will be following those areas of weaknesses or those cracked areas, such that they will end up having a rectangular shape. Compare drainage density of drainage basin A and B. When we are talking of drainage density in simple geographical terms, we are looking at the number of streams. Or we can talk of drainage density as the cumulative length. If we were to join all those streams, how long would they be? The cumulative length of the streams in the drainage basin. So if the length is high, or if we have a longer length of the streams, if we were to join them, we say it's high density. Or if the number of streams, we have to count them, there are many, that gives us high density. If there are fewer, that means we have a low density. So going back to our two drainage basins, if we try to check here and here, we tend to find that we have many streams here. Or if we were to add up the streams to get one length, we're going to get more a longer length in drainage basin B. So if you are comparing, we are saying A has lesser density than B, or B has got higher density compared to A. That is basically the comparison. A has lesser density, is a less dense basin compared to this, or this one has got a higher density compared to a drainage basin A. Right, moving on to the next question. Right, we are saying, discuss how vegetation contributes to a lower density in a drainage basin. Right, how does vegetation contribute towards less streams developing in a given area? What is the implication of vegetation on drainage density? Right, the first factor that you must know is that vegetation promotes infiltration, which means whenever we have a vegetation in an area, that area is most likely to have high levels of infiltration and less runoff. When there's high infiltration, it means there will be less sheet flow, or there will be less runoff on the ground surface. So it implies that amount of sheet flow or surface runoff is limited in that particular area. And what is going to happen because of less runoff, surface runoff in this matter, less streams will develop. Or we can say because of high infiltration, precipitation is fed into groundwater storage and not into the development of streams. So because of that reason, that is why we tend to have lower drainage density in an area with vegetation or in a vegetated area. It means the implication is that the vegetation is going to promote infiltration And as there's high infiltration, it means there's less sheet flow or there's less surface runoff. Because of the absence of surface runoff, it also implies that less streams are going to develop, because our streams are going to develop from surface runoff. And as a result, we are going to have less streams developing in that area. More of the precipitation is fed into groundwater storage and does not contribute towards the development of streams on the ground surface. Right, name the course of the river where the meander would usually form. The meander is a typical landform in the middle course of the river as we approach the lower course of the river. So typically, the meander is a landform which starts, which is predominantly in the middle course of the river, going towards the lower course of the river. That is where we tend to find the meanders developing. Right, draw a labeled cross-section of the meander loop along line A and B. What you must note here is along line A and B, we want to draw a cross-section. If this is our bend, we tend to find that this is our outer bank of our bend there, and this is our inner bank of our bend. And as a result, the outer bend, there is high velocity. And as there is high velocity here, there is erosion taking place. And as there is erosion, we have undercutting taking place on the outer bend. And here on the inner bend, there is less velocity. Because of less velocity, we tend to have deposition happening. And because of deposition, that is where we have the development of what we call the slip-off slope. Right. So we go back to our question. Our question is saying, draw a labeled cross-section of the meander from A to B. Right. We put our A here, and we put our B this side. Our A, we said there's deposition, implying that this is going to be a slip-off slope. It's a gently sloping because there's deposition. And we get into the river channel. As we approach B, there's undercutting, and our B is somewhere here. So the nature of our landscape will look like this. And what are we supposed to do? We are saying we must draw the cross-section. We want to check on the shape of the cross-section. Is it compatible with what is happening on either side? Right, we can check. Let me just correct this one here to make it appear right like this. So we are saying we want to label the slip off and the undercut. Right, we said our slip off is this side. Is where deposition happens. There's deposited material here. And our undercut slope, we find it on this side where there's erosion. And areas of fastest current flow, this is the area of fastest current flow. The flow is faster around this area, yeah, while this is slower on this area. If we were to indicate the level of the discharge in the river, it means water flowing around this area will be faster and will be eroding this side. And water flowing around this area will be very slow. So basically, that is how you must draw your cross-section. Make sure that the shape implies, and there must be a steep slope here, which is being undercut, and there must be a gentle slope on this side to indicate that there's deposition, and that's the shape of the sketch. And you must label your slip off on this side, label the undercut on this side, and areas of fast velocity, we find it on this extreme end of our river channel. Right. Moving on to the next question. The next question is saying, explain how the continued erosional and depositional processes in the meander loop will lead to the development of an oxbow lake. Right, we'll just summarize that by illustrating a meander loop and see how the meander loop is going to be ultimately eroded as the river manages to establish a straighter course along the river channel. Right, we are saying in this situation, we are having a meander, and that meander is giving us a meander loop, or a meander neck. Right. If this is our meander, and our meander is appearing again on the either side, our stream is having this shape, something like that. We are saying This is the outer bank of the river, and this is again another outer bank. We know well that on the outer bank, there is erosion taking place. So on the outer bank, there are cycles of erosion that are going to happen. Let's say this is cycle 1. And on this side, the same processes are happening. There's erosion. And there's deposition happening on the outer band here because of less velocity. And because of less velocity, there's deposition happening on this side. So we are seeing that our stream channel is gradually migrating in this direction, and also is gradually migrating in that direction. So with continued migration of the stream channel because of erosion on the outer bank and deposition on the inner band here, we tend to find that the meander loop, it becomes narrow and narrow. It narrows gradually until the cycles of erosion will ultimately manage to get to each other. If they manage to get to each other now, it means the river will manage to break its course via this. Instead of the river going this direction, circulating via this meander, it's no longer going around this area, it's now going to break through this former meander loop, which means now the new course of the river is now this one. The new course of the river is now flowing via this shaded area here. The river is no longer meandering, but now is following this straighter course going in that direction. And there will be deposition happening around this area that is going to cut off this part, which was a meander, is going to be cut off by deposition, which will happen on either side of the loop here. And this will now develop as an oxbow lake. That is basically what you must explain there. You must explain that erosion happens on the outer band, and the outer band is going to migrate. Deposition will occur on the inner band, resulting in the complete shifting of the river channel. And as the two river channels are migrating towards each other, apparently they will get to narrow the meander loop, and apparently they are going to break the meander loop, and the river will attain a straighter course and will seal off the former meander as an oxbow lake. Right. Let's move on to the last question, number 2.44. The developer has chosen to develop a holiday resort at Area D. Explain why this choice of site is favorable or is good location for construction. Right, let's go and check on our illustration. Area D is here. This is on the inner bend of the meander. There's a bend along the river channel, and area D is on the inner bend. We are saying this is an area favorable for the development of a resort. Why are we saying that area is justified for the development of a resort? Number one reason, we can say there's less erosion risk. We know well that on the inner bend, there's deposition taking place there. So, because there is dominance of deposition, so it's a stable place. Because there's less erosion risk, the area is less likely to be eroded because there's dominance of deposition. And also, it's a more stable ground. Because of continued deposition, the area becomes more stable. It's a stabilized area because of the deposition that happens. It has potential, the area, for scenic environment. There will be a scenic environment there because of the deposition that happens. People can ultimately go on sightseeing on the area. It's potential for sightseeing, or it's a scenic environment because of the deposition that happens there. And also, there's less risk of flooding. Remember, water on the outer band flows gradually, which means there's less risk. And also, the slope of the area is gentle, implying that it can accommodate large volumes of water on that side. But the undercut slope, there's high risk of flooding on that area. So there's also less risk of flooding on this side here. So that justifies that. Why is it an area with potential, or which is favorable for the development of the for the development of a holiday resort over that area there. Right, moving on to question 2.5. Question 2.5 is based on water and river management. Right, the first question is saying what is river management? This is a geographical concept. We can define this in our own understanding, but we must address the basic idea of river management. Right, we can say is the maintaining, or we can say is the preservation of water bodies and catchment areas. Why do we maintain the water bodies, or why do we preserve them? To ensure sustainable availability of clean and fresh water. So when we are managing rivers, we are actually talking of a composite situation of maintaining or restoring or preserving our water bodies and our catchment areas, our drainage basins, with the aim of attaining sustainable availability of water. Sustainability, we are saying we need long-lasting availability of water, or guaranteed availability of water for the next generations. And that water is critical. We need water for different purposes. That water, we can use it for domestic purposes, or we can use it for industrial purposes. So we have to sustain our water bodies. Right. What does the abbreviation DWS stand for? That is the Department of Water and Sanitation. Right. Provide a quote from the extract showing how water lettuce and water hyacinth disrupted the Vaal River ecosystem. Right. We can check in the text. It says, for several months, the Vaal River had been plagued by a rapid spread of water lettuce and water hyacinth. The quote, choking out native plants and animal life. So that is the implication. They have disrupted the Vaal ecosystem. They are choking out native plants and animal life. Right, moving on to the next question. Explain why it is important to ensure the health of the Vaal River for Gauteng. For the Gauteng people, why is it important? Right, in Gauteng, the Vaal River is used for extraction of water for domestic use. And the Vaal River is also used for the extraction of water for industrial use for the Gauteng people. And also is used for recreation for the Gauteng people. So it's most important that we ensure the health of the Vaal River for those activities to continue happening. There are recreational activities that happen in the Vaal River, in the Vaal Dam. We need water for domestic use. We also need water for industrial use, and ultimately for the sustenance of jobs for people in the industries. They rely on the water from the Vaal. So we need to ensure that there is healthy sustenance of the Vaal River. Right. In a paragraph of about 8 lines, propose measures that the Department of Water and Sanitation can implement to ensure future health of the Vaal River. There are so many strategies there. We can talk of legislation. Legislation, they can put in place laws to protect the river. Or we can talk of buffering the river, where we put demarcations to avoid human influence on the river. And in this instance, we will talk of negative human influence. And we can also avoid settlements along the river. Or we can also talk of heavy fines and penalties for those who are seen polluting the river, or we can talk of law enforcement. Maybe we need to put security to man the river and ensure that the river is safe. And also we can talk of education, educating the general public on the dangers of polluting the river, or we can also use awareness campaigns to make sure that people are conscientized of the need to maintain the rivers and the catchment areas so that the Val River is kept healthy for future uses. So those are some of the strategies that you can talk about. Right, we finally move on to our last section of the paper, which is the geographical skills and techniques, which is our Mapwork section. Right, Uppington is a town located in the Northern Cape province of South Africa on the banks of the Orange River. It sits at an elevation of 835 meters above sea level. Uppington is the closest large center for the Agrabis Falls, arguably the greatest of South African waterfalls. And then Kalagaji Transfrontier Park, the landscape is very arid, but the soil is fertile, allowing crops such as fruit to be grown in irrigated fields. Uppington has a hot desert climate with long hot summers and short mild winters. Precipitation peaks during the late summertime. Right, that is the information. So our first question is saying the contour interval on the topographic map. This should be information at your disposal. We need to refer to the map and try to find out. The contour interval on the map, on the topographic map, is indicated here. Contour interval is 20 on the topographic map. The information is provided here. Contour interval in English and contour interval in Afrikaans is provided here. So that is information at your disposal. You must always remember the contour interval on the topographic is 20 meters and the contour interval on the orthophoto map is 5 meters. That should be information at your disposal, the disposal of your fingertips as a geographer. That's 20 meters. Uppington is situated in the Dash province, which is what kind of climate? We have talked about that. Is in the Northern Cape province. According to the map information, our Uppington is located in the Northern Cape province. And also what kind of climate does it have? It has typical of a desert climate. So it's item number 2 and item number 3, which are combined at letter B. Identify the map which is located west of 2821 AD. That you are doing your map referencing. Remember, we must draw our referencing like that. Right? We are saying our 28 is for latitude, which means this is 28 degrees. And this is going to be our 29. And this is going to be 21. And this is going to be 22. So we are saying in this block, we have subdivisions of our map. This is our bigger block A, and in this bigger block A, we have small subdivisions, which is AA, AB, AC, and AD. So we want a map which is to the west of 2821 AD. Right, our AD is this one here. Right, so a map to the west, the western direction, we are looking at this side, west, this is our east. So to the west, we want the reference of this map. The reference of this map is still the same reference, 28, 21, we are in the same block, we did not change. And our bigger block is still A, our smaller block is now C. So this is the reference, 2821 AC. This is the map to the west of this given block here, right, using our grid referencing. Right, we move on to the next question. Refer to the orthophoto map. Calculate the area of the recreational ground labeled 6. Right, let's check on the area labeled 6 on the orthophoto map. This is our area labeled 6. We have this recreational ground, this one here. Right, this is the area that we want. The question is saying calculate the area of the recreational ground labeled 6 on the orthophoto. Right, in blocks A3, A4, and B3, B4 in meters. Use the following information. The breadth is 80 meters. So the breadth, it means this is the width, which is been calculated for us, which has been measured for us as 80 meters. So what we need to do here is to try and find the length here. How do you find the length? You measure your length using your ruler. You find the measurement from the map in centimeters. And remember to convert to the map scale. Our map scale is 1:10,000. So when you want to convert this, you are now saying your measurement. We go back to our question paper. We are now saying your formula is length times breadth. So you get your length in centimeters, your measurement, you multiply by the map scale, which is 10,000. If you want to multiply this directly to meters, you multiply this by 100 meters. So if you check your measurement, you multiply it by 100 meters. And you check your width, you multiply it. It's already been given for you. Your breadth is already in meters. So you need to convert your measurement to meters. And according to our calculation here, I've got the length as 100 meters, which is multiplied by 80 meters. That is going to give you 8,000 square meters as the area of that particular recreational ground. So what you only need is to measure, and you convert your measured distance according to the map scale of 1:10,000. You give your measurement in meters, and already your breadth has been given in meters. You multiply the two to get your answer in square meters. Then it says calculate the gradient from spot height 815 in block C4 to the trigonometrical station 71 in block D1. Right, use the information height measurement as 24.2 meters. Right, 24.2 meters. That is your height measurement, right? Which implies that what you need to do here when you're calculating gradient, let me simplify that. Let's go to our area between spot height in block C4 and trig station in block D5. C4 and block D5. Right, going back to our map, this is our topographical map. We are looking at block C4. Our block C4 is here. We have our spot height here. I think you can see where it is. And also we have our trig station in block D5, which is station number 71. So what you need to do here is for you to get this measurement that you need here, you need to get the VI. Our VI in this instance, vertical interval, is the difference in height between the two features. We are saying one is 847.9 and the other one is giving us 815 exactly. Right, so it means your VI, you are saying the smaller height from the bigger height. So which one is smaller and which one is bigger? The trig station is higher than the spot height. So you are saying 847.9 minus 815. This is already in meters. Over your horizontal equivalence, you are given the distance as 24 point, the height measurement, sorry, it says the height measurement is 24.5 meters. So what you need to do here is the horizontal equivalence. You are supposed to calculate your horizontal equivalence by finding out the difference between the 2 points. Here, the straight line distance, you multiply it by the map scale of 50,000, which means you multiply the measurement by 500 to get your distance, actual ground distance between the two features. So, which means your vertical interval is in meters and your difference between the distance between the two features is also in meters. If you multiply the measured distance by 500, then you now have to divide by the value of the numerator. You divide the numerator by itself, and you divide the denominator by the value of the numerator, such that your answer is a ratio with 1:2, a given value. You convert this numerator to 1, you make it unit by dividing by itself, and what you have done to the numerator, you also do to the denominator. You divide the numerator by itself, and you also divide the denominator by itself, and you apparently go to give your final response as a ratio with a numerator equal to 1. So that will give us the value of our gradient if we calculate. Then refer to the area between spot height 815 and is the area suitable for crop farming? We are referring back to the same area, this area here. Right, the area is unsuitable for crop farming. This area is unsuitable for crop farming between this trick station and this. We are saying this area specifically between these two areas is unsuitable for crop farming. Provide evidence from the topographic map to support this statement. Right, one piece of evidence, if you check, there is a high drainage density in this area. There are so many streams, which exposes the risk of flooding. The area can be flooded if it's the rain season because of high density of streams. There's risk of flooding. That is why it's unsuitable. And also, we can argue that there can be limited water supply in the dry season. Why? Because all the streams that we are seeing here, they are non-perennial. Non-perennial streams. It implies that during the dry season, these streams will be dry and the area won't be having any supply of water for irrigating the crops. During the rain season, there is high density of streams, which can also result in flooding of the area. So that is why we can say it's unsuitable for agriculture or for farming purposes. Right, moving on to the next question. We are moving on to question number 3.2 on map interpretation. The first question, we are going to our question paper. Right, the first question on map interpretation, it says the temperatures at the built-up area in block B1 is warmer than the surrounding countryside in block D3. The concept describing this phenomenon, we are referring back to a concept where we have an urban area which has got a higher temperature compared to the surrounding countryside or rural area. That is typical of an urban heat island. A solution to this phenomenon, answer to question 321, is creating more green belts in this built-up area. If you want to reduce urban heat islands, we must create green belts. Define the concept green belt. What is it, what we call the green belt? We are looking at the introduction of vegetation or vegetative cover to an urban area. If we introduce vegetation or introduce vegetative cover, we are creating a green belt. A green belt constitutes of vegetation in an urban area or in a built-up area. Then the next question is saying, provide evidence of green belts in block B1. We need to check block B1 and try to check the evidence of existence of the green belt. Right, in block B1, we are seeing in this area, if we check this part here, is having this feature, this green feature here. Right. So if you check this area here, what kind of introduction of green belt has happened in that particular area? So we can see we have some rows of trees in that area. As we see along that road, there is a row of trees, and also there are some trees in that area along that other road there, that is in block B1. So we can safely conclude that there is the introduction of vegetation in that particular area as an attempt to try and reduce the effect of an urban heat island. And also, if we check, there's evidence of a recreational ground in the same block. That is also typical of evidence of introduction of green belts in that particular block. So whatever has to do with vegetation introduction in the area constitutes as part of the introduction of the green belts, or as evidence of the green belts in the area. So you check on features like if there's a woodland, or if there's a row of trees, or if there's a recreational ground in the area that constitute part of the evidence of introduction of green belts. Right, then we go to the next question, number 3.22. It says, refer to block C4 and block D4 on the topographic map. Calculate the stream order at X in block D4. Let's go to the map and check the stream ordering at X here. Right, if you try to check at X, we tend to find that when you're doing our stream ordering, I think you still remember, our stream order comes like 1 plus 1, 1 plus 1, stream number 1 plus stream number 1, they give us stream number 2. Stream number 2 plus stream number 1, they still give us stream number 2. Then stream number 2 plus stream number 2, they give us stream number 3. 3 plus 1 is equal to 3. 3 plus 2 is equal to 3. 3 plus 3 is equal to 4. And the order goes like that. So we want to check here and try to identify the stream order around area X. Right, we trace the stream which flows past X. The stream which flows past X, we can actually see that is this stream coming from this direction of the eastern direction, which is northeastern, right? So if we check, this stream is starting here, and this one is starting here. They don't have tributaries. This is stream number 1, and this is number 1. And they are having a confluence here to give us stream number 2. If we trace this one again, you find that this one is starting here, and this one is also starting here, which means this is number 1, this is number 1. Number 1 plus number 1 at this confluence here, they're going to give us stream number 2. So this confluence here, before we get to X, is a confluence of 2 plus 2, which is stream number 3. So the order at X is a third order, or is stream order number 3, which is made up of 2 plus 2 to give us 3. Right, we move on to the next question. Right, the next question is saying, where is the drainage density higher, in block C4 or D4? Let's check C4 and D4. Right, block C4 is this one. C4 is this. And block D4 is this one here. Let me erase this. We are saying drainage density, we are looking at the total number of streams in the basin, or the total length. If we check here, there are many streams, meaning to say there is a higher density here, and there is lower density there. So higher density is in block C4 is higher density, while D4 has lesser density. Right. We are moving on to refer to the orthophoto topographic. Stream channel flowing between 7 in block D1 and 8 in block E2 is braided. Provide the evidence from the orthophoto to justify this statement. Right, if we check on the orthophoto map, it says a stream which flows between area 7 in D1 and area 8 is braided along this line here. What is the evidence? Right, we can see that this is an island. There is an island within the river channel. So it suggests that the area is braided. We are having this area here as an island within the river channel, which means the river is braided. What is the name of this braided stream? The name is here. This is Orange River. We have our Orange River here. Explain with evidence the main reason for the development of the braided stream in question 323A. Why is it that we have braids in that area? The reason why, the justification of having braids there is less velocity of flow, and because of less velocity, there is more deposition. And mainly because of general gradient. The area is gently sloping, is giving us less velocity, and there's more deposition. The deposition is the one that constitutes the development of braids, because the river is now depositing its load within its own channel. And as a result, there will be braids developing in the river channel. Right, number 331, we go on to the question paper. Right, it says, choose the correct option to make these statements true. Descriptive data on a map is also referred to as what? What kind of data is that? That is attribute data. Descriptive data is attribute. Data manipulation or data integration involves combining data. When we're talking of combining data, we are integrating. That is data integration. Refer to block C5 on the topographical map and identify the following features. Let's go to block C5. If we check on block C5 on the topographic map, we are referring to block C5 here. Our block C5 is here. Let us try to analyze that block. Let's erase this information. Right, our block C5, we want to try and analyze. We want to identify a natural line, which is a water feature. A feature which is natural, which is presented as a line and is a water feature. Right, block C5 is this block here. We are worried about features in this block here. This is our block of reference. Right, if we check line features, we have so many streams there. So our line feature, which is natural, is a stream. There are streams there. Those are our natural features which are in the format of line, and they are water features. So that is for A. For B, B wants us to identify human-made polygon feature. If you check here, this is a polygon feature. It's an area feature, this one. And also if you check this one, it's also an area feature, which is a polygon. So our polygon feature in that matter is either an orchard or it's a vineyard. That is our human-made polygon feature. Then number C, it wants us to identify a point feature. A point feature in this instance is our spot height, which is our spot height 834. So our spot height is a point feature in that block. Right, those are our features. Moving on to the next question. The next question is saying, refer to the statement below and about Orange River located in block B4 on the topographic map. We want to analyze our Orange River in block B4 on the topographic map. B4, our block B4, we are referring to this block here. This is our block of reference. Right, the question is saying, buffering is evidence on either side of the Orange River. Define the concept of buffering. When we're talking of buffering in geography, we are looking at putting a demarcation or a boundary along or around a geographical feature. That is buffering. We are putting a boundary or a demarcation around a geographical feature. That is demarcation or boundary. That is buffering. Then provide evidence from the topographical map that buffering is occurring on either